Hey, Jennifer and your group, thank you so much for the invitation to speak at the summit. You'll notice that my presentation is based actually in the Keys, but I can assure you that the few things that we're going to talk about this afternoon very much fit right into coastal Southwest Florida and things going on in that part of the state. So again, it may be kind of based in the Keys, but it definitely transfers over to Southwest Florida. All right, so in the next slide, what I wanted to kind of point out, you guys have gone through a lot of science today, really, really good science. And I just wanted to do a real quick, hit the top of some of the most important aspects of the climate and where we are today, actually. As far as carbon dioxide, the CO2, as of, last month, yes, we're in April, we actually have quadrupled the amount of carbon dioxide in our atmosphere since the 1960s. And you heard earlier this morning, someone talking about the ice cores, which are almost 1 million years old, and all the way out to that time, we are now in the highest amount of CO2 in the atmosphere, going all the way back to those ice cores. So yeah, so we're definitely way ahead of the game for sure. Now, when you look at the global land and ocean temperatures, they have increased by over a degree Fahrenheit from the 1981 to 2010 average. This has tied the warmest year since the mid-1800s record. Also, global humidity has decreased while our evapotranspiration has actually increased again this year, highest on record. Arctic land surface temperatures have also increased by almost 4 degrees Fahrenheit, second year, highest year since 1900. Our glaciers, unfortunately, have lost mass for the 33rd consecutive year, almost losing about 2 feet. Again, that's really a critical loss for us. And lastly, the sea ice melt is now at the second highest since 2005. Now, you'll notice that 2005 is actually highlighted, and I'll show you why. In the next slide, you'll see that we've been on a linear increase for sea level rise through most of our history. But starting around 2005, 2006, the question is, did we hit a tipping point? Because then we began what you see right there in the middle of the graphic, an exponential rise in sea level. So, when you start looking really deep into the data, there seems to be somewhat of a tipping point around 2005 and 2006. All right, next slide. We're going to get into the Keys. And it's really important to understand the geology of the Keys. And for those of us, most of us have been in the Keys, you know that they are really low elevation. About 80 to 90% of the islands are at or below 4 feet elevation. So, that's the one thing really going against the Keys, is that it's not going to take much in sea level rise to inundate the islands. Another thing about the Keys in the next slide is the geology of the Keys, and that includes Big Pine Key, which hosts one of the only pine rockland ecosystems around the world. And the thing that I wanted to point out is, in this type of ecosystem, it's made up of slash pine trees. And those roots, as you can see from this photograph, go down 1.5 feet to almost 3 feet. And that's really important because, as we look at the next slide, Big Pine Key is very dependent on the freshwater lens. All of the vegetation is dependent on the lens. The key deer, a threatened and endangered species, is very dependent on the freshwater lens because there are solution holes in the island where there is some seepage into the solution hole from the freshwater lens, but they also catch rainwater. So again, we have that freshwater lens. And as you look at the graphic, the top graphic, you'll see that at the very top elevations of the island, you've got your coastal hammock. your big pine ecosystem. Then as you start to move down gradient, you get into the buttonwoods, and then you get at sea level, you've got your mangroves. As you get in, as sea levels rise, we move into the bottom graphic where the freshwater lens is shrinking, which is being documented every year on Big Pine Key. The salt water is moving up and moving in from the sides. And so what is happening is we're losing the slash pine, we're losing that pine ecosystem, pine rockland ecosystem. That's being taken over by the buttonwood, which is moving up gradient, trying to get away from the seawater. And then the mangroves are moving up gradient, taking over the place of the buttonwood. And the mangroves that are being overtaken by sea level, those are dying off. So the Big Pine Key is extremely dependent on the freshwater lens. Next slide. So when I was working with some managers and decision makers during the key deer status decision-making process, I kind of started running into just a miscommunication between the science and folks who are making decisions. They're not scientists. They're not dealing in climate change every day like I was. So I started noticing some disconnects, and I'm going to share those with you. And feel free to use this with your public, with other stakeholders, with managers, decision makers, because this graphic in and of itself right here is very confusing. First of all, upper right-hand corner, you see the nomenclature, just the naming of the scenarios. That just meant nothing to my managers. They're like, what is extreme? What is intermediate, high or intermediate low? What does that mean? So I knew I had to do something, first of all, about the naming convention. Secondly, it seemed that the manager's eyes were going from the year 2000 on this graphic over immediately to 2100. And they're like, whoa, look at that uncertainty. It goes all the way from 11 feet down to nothing. How are we supposed to use this? This doesn't mean anything to us. So I knew I had a problem with probability versus uncertainty. And what I had to finally try to get through to the decision makers is that the level of uncertainty is not out there at 2100. It's not that wide division among the scenarios. The highest level of uncertainty is right now because it's based on human behavior. And we're still, as a species, trying to figure out what the climate needs and how we're going to react to this. And until we know how we're going to react, we don't know which line we're going to be on. But once we know and we get on that line with the latest modeling, we're pretty certain where we're going to end up in the year 2100. So I wanted to share that with you. Those were some of the biggest problems I had in trying to relay climate science to decision makers. Now, in the next slide, you'll see how I confronted this problem that I was having. First of all, about the naming of the scenarios. I took the names out and I just put a descriptive phrase next to the scenarios. So instead of the extreme, NOAA extreme, what that basically means is that we're now taking, or the NOAA models are now and USGS are now taking in the potential for rapid ice melt. They're like, oh, so that's the difference between that line and the next line that you call business as usual. Yes, exactly. So business as usual means we don't change our behavior at all. The next line is if we get our act together. Sorry, go back to the other I'm sorry. I did say next. So the following line, the yellow line, is if we get our act together and we start decreasing greenhouse gases by the year 2080. And then the line below that is what happens if we start getting our act together a little bit sooner in 2060. You'll also notice that I took the bottom three lines away because the NOAA USGS paper identified that there's a 96 to 100% probability that the lower three scenarios either already have been or are about to be exceeded. So I wanted to take that confusion away from the managers. So I removed those three lines. I also added two more lines. You'll see that the top blue line that says 1,007 acres, that's the 3-foot elevation mark on Big Pine Key. That's where we're going to be when we're left with, when we have sea level rise that comes up 3 feet. The next bottom line is the root zone line. And that's taking it down to that 1.5 foot that we just talked about with the slash pine. So that's where my root zone is, according and along the line of the scenarios. And that is also where we start running into the freshwater lens impacts. Okay, now next slide. Another thing that I did to alleviate and to bring home a very powerful statement to the decision makers was they kept going, yeah, but in 2080 or, in 2100, and I'm like, stop. So if you just take the scenarios off where that island becomes almost completely inundated, I took those lines completely off of the graphic because that island doesn't care anymore. It's practically, it's practically underwater with the exception of 1,000 acres or about 12% dry land. So that really, they were like, oh, whoa, oh, okay. So if we're looking at the potential for rapid ice melt, if we're looking at that line, then we're looking at maybe in 2030, we're going to start seeing these trees die off. Yes, absolutely. And so you can see as we move through those scenarios that, things start to happen a lot earlier before the island is completely inundated. Okay, next slide. What I want you to do is really focus on yellow, which is dry land, and green, which is mangrove. This is with 1 foot of sea level rise using the sea level affecting marshes model, or SLAM. The next slide is with 2 foot. All right, you see how the yellow kind of changes and it just starts to disappear. Next slide is 3 foot. And the final slide here is actually 4 foot. Did you see how the yellow disappeared? The green mangrove really increased, and where the mangrove was is now open water. Next slide. The environmental trends that we're talking about here is vegetation succession. This graphic now takes everything you just saw in the model. Look at the yellow, that's the developed dry land. You see as we go and increase sea level rise, that the yellow decreases, so we're losing our developed dry land. The light green is undeveloped dry land. As we move to the right, you see that we're losing our undeveloped dry land, but the dark green columns are your mangroves. And with sea level rise, we're increasing mangroves. Next slide is what could happen to development on Big Pine Key. The upper left-hand corner was in 1959 before a neighborhood was built. And you'll see through 2002 and 2015 what that neighborhood looks like today. The lower right-hand corner graphic is I placed 3 feet of sea level rise on that neighborhood. It is now completely disconnected from any other land, and it is surrounded by mangrove and open water. And the pink that you see there, that's going to be the fill they brought in to raise those houses up above sea level rise. Next slide. Another important environmental trend that we're going to see is significantly affected species, some that might even completely disappear in 2100, everything from reptiles to birds to plants to cactus to butterflies, key deer, you name it. Okay, so then I just want to wrap up here real quick with the next slide, which is basically the take-home messages. It's in your planning. Again, remember the root zone impacts. They're going to happen almost sometimes a decade before sea level rise comes in and affects the surface of the land. So root zone impacts are really important to kind of move up on your priority list and start looking at that as a community. Also, bring in those scenarios, bring in the sea level rise scenarios into your planning activities. And remember, try to use vetted, well-known sources. You know, my go-to is NOAA, USGS, a lot of our local universities. That's just to name a few. That's not, I'm not endorsing. But anyway, you know, so make sure that they're vetted and that you can totally count on them to have the very best available science to back up their thoughts and their modeling. Also, those scenarios have degrees of certainty. They're not intended to be associated with probabilities. That was kind of used during some of our decision-making processes where probabilities kept coming in. It's like, no, 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 it's uncertainty. Also, if I can, another thing I want to talk about very quickly is implementing stakeholder-driven conversations. Those are incredibly important. Bring in as many differing, diverse stakeholders as you can. Start looking at local adaptation strategies, not only for the urban areas, but for your species and for your natural systems. Not only for the long term, but also start thinking ahead. We may need some temporary space to move critters until we can get to that permanent solution. Also, bring in as much of the modeling tools as you can into your decision-making efforts and connect those future environmental trends into your assessments. When I say future environmental trends, look at the changes in rainfall rates, the changes in sea level, the changes in how the precipitation patterns are going to change. Bring all of that into your assessments and into your adaptation strategies. Lastly, my last slide is very simple. What do we do with this? This is a picture of Big Pine Key today, and that is a picture of a simulation of what Big Pine Key can very well look like in 2100. Thank you. Yeah, so RSLC, I am so sorry that I didn't correct that on there. That's called rising sea level change, because some areas along the coast are actually going to be going through some uplift instead of some subsidence. So it just means the level change, whether it's going up or going down. Let's see, what can we do to help as a wastewater utility? I love that question keeps coming up, because it is really important. There's wastewater utilities even on Big Pine Key, and being with the National Wildlife Refuge System, we have actually worked with the utility company there, a wastewater utility company there on the island, on just looking at what's the best way to set up the infrastructure to not impact the freshwater lens or not impact the refuge or habitat for, let's just say, I keep coming back to the key deer. So that's how you can help, is just really continue to be a good stakeholder and a partner with all of the scientists and the agencies. That's just critically important. That's the best thing you could do. Let's see, would beach nesting birds raised platforms be effective in the Keys adaptation strategy? It could be in certain areas. I know I worked in the Midwest for a while along the Kansas River, and I do know that there was a nesting bird that, the Army Corps came in and actually lifted the nest to kind of get them through the rising and lowering of the river as storm events came along. But it would only be a short-term strategy, I believe, because the sea level is coming. And so it's going to be a point where it was something that you would just have to keep moving upland, and moving upland. Something to think about in the temporary. I mentioned temporary versus permanent. So that is definitely something to add to the toolbox, I think. What are policymakers doing to adapt to these changes? In my agency, the U.S. Fish and Wildlife Service, and with the National Wildlife Refuge System, the program that I'm with currently, I see policymakers doing a lot. They are really staying involved with the science and really working with our natural resource managers to make sure that, we need to replace the building. Okay, well, let's not replace a building that we're showing sea level rise within, with 2 feet, and then the building's toast again. So the policymakers are really staying tied into the environmental trends expected for each individual National Wildlife Refuge, and really taking that into consideration when either replacing or adding new infrastructure, or even moving a visitor center, or building a boardwalk. What's smart as far as sea level rise is concerned. To mitigate the effects of sea level rise in the islands and Florida. You know what? The reef system is highly critical. The coral system, highly critical to being able to mitigate some of the effects. The problem is that we are seeing over and over is that if sea level rise would just slow down, take it easy, let's just do this slowly, we may be able to keep up and ahead of it. Maybe back build, some islands. I've actually heard that being proposed that, maybe we start dumping sand on some certain sides of the island. But you know what, with the exponential rise in sea level, I don't think that's really a viable idea, because I think honestly, Florida knows it. Florida has been underwater before. It's been a lot wider than it is now, the peninsula. The Keys have been there. The Keys have gone away. Unfortunately, it is just a part of our history. And I'm going to keep going, Jennifer, until you tell me to stop. I know we're getting close to 3.
No, then feel free to take a few more, please.
Okay, great. Is adaptation realistic in the long term? You know what it's doing? It's buying us time, as you mentioned, in the long term. It's buying us time. What do we do? Let's just pull out, let's say the beach mouse. It can buy us time to maybe even find a better place, maybe on the peninsula of Florida. As the Keys go underwater, there may become some coastal areas that'll be, super fantastic maybe for the beach mouse. We don't know. To me, it is definitely, as far as the Keys are concerned, it is buying us some really important time to be able to come up with a really strategic plan, for the key deer also. Anyway, so the next one is, what can you predict, say, about Sanibel Island, which I understand is only 3 feet above sea level? It's a lot of the barrier islands along the east coast of Florida and the west coast of Florida are looking at the same type of effects as the Florida Keys. So I would say stay partners with your Florida Key, with your the Florida Keys group, and we're all in this together. So it's something that we're going to have to work with, because all the way up to Cape Canaveral, though the barrier island will eventually go underwater. So that's something that we're all going to have to deal with along the coast. Let's see, reduction in CO2 never seems to be discussed. It's what increases sea level rise, so why not address it? Right, and there's all kinds of forums for that, right? We could say, we're monitoring it, and it's all comes down to policy, and we're talking policy way above us, in DC and beyond on a global scale, and I think, and that's what, when I was showing you those scenarios are kind of based on your question. When are we going to be able, and are we going to be able to reduce the greenhouse gas emissions? And if we can, then things will slow down a bit on us. If we can't, then you saw the scenarios just really taking off and doing a lot more harm as far as sea level rise if we can't get it under control. The reduction of CO2 is probably one of the most important topics. And it just seems like, us scientists here with our boots on the ground, we talk about it. Where, how can we use carbon sequestration? Well, what can we do with this wetland to kind of bring down carbon or increase carbon sequestration? So it's something that on so many levels it seems like it's just growing in some areas and stagnated in others. It's something that we're going to have to all come together on, I think, to make this work. And as you know, we're running out of time. So speaking of running out of time, I think I've got one more. In your experience, do policymakers understand that rapid development along low coastal areas is exacerbating these issues? Yes. In my experience, they understand it. I feel there's a lot of pressure to continue to develop. So, until we can kind of get urban development in a better plan, I see urban development really taking off. It is exacerbating some of the problems. And with us being in the low coastal areas, we're increasing flood insurance just because they know it's going to flood. And so we choose to continue in that area. So Anyway, I know I've run out of time. I'm about a minute over. So thank you guys, all of you, for all the great questions and continuing the conversation. Keep up the fight.